Welcome back, everyone, to the another episode of the Ramda Deep Dive Season 2, followed up by the excellent series by Christopher somebody. Can't remember his last name. Um, but I've been rewatching the end of the original series. I'm somewhere in the F's where the episodes get really long, and then there's the cat breaks. Um, but I kind of counted through. I think there's about 230 some functions in Ramda. Since that series, some new functions have been added and some were deprecated. Um, and then as we looked through each function, it would say something like see also pipe. Let me zoom in a bit on this one. Yeah, like see also, and then so I think that by the end of Chris's series that ended with filter, um we he probably looked at half of them. So we're probably past the halfway point at this point. um and there's a lot of functions built into Ramda that are also array methods or string methods built into native JavaScript. However, Ramda uses the philosophy of data last, curried automatically, um, so it can be composable, so more convenient for functional programming. But, now we're down to flip, and flip is not something that's built in to JavaScript by default. I mean, you can make your own very easily. We'll do it in just a second. But I think these are kind of more interesting because, we're not just rearranging the order of something that already exists. I've also made some progress in understanding these type signatures. And one of the recent ones, I think it was chain. This is just a quick side note. Yeah, where we have these M's. Um, M is something that's chainable, which I think M stands for monad, because a monad needs to have a flat map method on it, which is called chain in Ramda, also known as flat map. So the M would be, we're saying the chain takes a function that takes any type, we'll call it A, and returns a monad of B. And then we pass a monad of A's, like a list would be a monad, and it would return a monad of B's. So before, I was confused when I saw these two arguments next to each other. I was thinking maybe this is a function applied to A, but that's not the case. So I just wanted to correct myself there, and we'll see an example of it as we move forward. But let's get back to business. Let's get back to our flip. Here we go. So flip is one of the things organized into functions, where flatten is a list method or an array method. And it's also super cool that I found that a lot of these array methods work on objects as well. Like you can map through an object and or filter an object, and you can't do that in native JavaScript. Anyway, I'm totally off topic. Let's get back to flip. So let's read the definition. Flip returns a new function, much like the supplied one, except that the first two arguments order is reversed, right? So the first thing I thought about when I saw flip, because we've looked at flip through the first series, um, I was wondering what happens if you have more than two arguments, and the answer is nothing. It just handles the first two arguments. So if you have a variadic function and you need to flip all of the arguments, we'll have to use something other than flip for that. Uh, and then let's look at the type signature here. So here's this is the return type here, and all of this is the input. So it takes a function, that takes, it's variadic, so it takes any number of arguments, A, B, C, ellipses, and returns a Z, right? So, a function basically it can be any function, really, any function that takes however many arguments and returns a value. And then, so when we give it that, when we apply flip, I'm trying to think of the correct way to say it. If we apply flip to this function, I think that might be correct. But let's just more traditionally say if we call flip and provide a function, then it will return to us the same function, right? Much like the supplied one, the same function. However, it just flips the first two arguments. So it gives us a function that takes B and A instead of A and B, but the following arguments are still going to be in the same order, right? And when we're doing functional programming, it gets complicated really quickly when we deal with functions with multiple arguments. It's much nicer when we have one and only one. I guess it would be even the next easiest would be a nullary function that has no arguments. And then once we have two, gets a little more hairy, especially when we want to try to compose things or pipe things. And then once it gets to many arguments, a variadic function, you can see how many things we've looked at already that wrangles that, makes it so it's composable. Um, but let's just do an implementation flip. Let's say we let's see, do I have console log? I do. Uh, so let's log hmm, something simple first. So let's say we have a function called add, right? And somebody showed me a trick. When you have two arguments, sometimes it's easier to do like A and Z instead of X and Y. Something about the distance between those letters makes it easier to understand, especially when you're dealing with a sort function. Um, it it's a psychological thing, and it may not make sense to you, but sometimes I like to do it. We'll do that, A and Z, and then we're gonna return A plus, you know, nothing, no mystery here. So if we did that and we call it with three and two, we run this file. Oh, I forgot the little thingy. Sorry, Control L. Yeah, we get five, right? And then of course, if we called it with two and three, we're still going to get five because addition doesn't matter as far as what arguments, what values are added in which order. You can put parentheses around here if you had three arguments. But, if we make our own subtraction, it gets a little harder to think about, right? So, that's pretty straightforward. But if we do subtract, um, are we subtracting two from three or three from two, right? So without thinking about it, let's just see what answer we get. And we get a -1. So we're subtracting three from two, but that's not necessarily apparent. It depends on what we're doing. So, you might say, okay, well, this subtracts the second argument from the first argument. Maybe we could have a function called sub by, and that would take an A and Z and subtract the A from the Z, the the first argument from the second argument. And then if we call that, we get one, right? So that's saying 3 minus 2. So we could say subtract by 2 from 3, right? But then, and of course, subtract is built in to Ramda. Um, and so let's do that. Let's see what we get. I think it's called subtract instead of sub. Yeah, it is subtract. Yep, subtract. Um, so what are we going to get at this point without like looking at the function signature? Like we're kind of guessing, right? So it's like the first one I made, sub, you know, but what if we wanted to flip it? So what we could do is we could use a flip function here, and we could say track by just to have a different name than the one I created, and use r.flip and flip those two arguments, r.subtract, right? So then we should get an error. R.subtract by is not a function. Oh, yeah, it's not. That is true. Yeah, and now we get one, so now we're flipping the order. So we could make our own flip. We could say const my flip, and it's just as easy as saying you take two arguments, A and Z, and then let's see, my flip takes two arguments, A and Z, and then we're going to need to take the a function, right? So I wondered if the function should be first. Hmm. Let me think about this. We took a function first. I mean, maybe we could do it in any order, but typically functions, like callback functions, are provided first, right? Yeah, because we were saying r.flip and then the function. Yeah. So then we need some arguments. So let's say as an arity of two, we're going to take A and Z, and then we're going to apply the function with Z and A, right? Would that do it? Is that the same function? So let's say we want to take my flip and apply that to r dot subtract. I have a feeling this isn't going to work, but let's see if it breaks and figure out why. And it does, right? So, and then if I pass the arguments in the second order, I get -1. So, yeah, I mean, it's not too difficult. Now, if we had more, I'm going to go back to A and B because I'm going to add more arguments. So, if we had a C and a D, then it would call like this. And it's JavaScript, so it doesn't care if we don't pass all the arguments to it. So nothing should break here. Go back 2 and 3. Here we go 1. Um, yeah, so let's look at the implementation real quickly just to see if it's not crazy. So it's calling curry one. Oh yeah, because curry one, it only takes a function and then returns curry in, and then so we get the length of the function that tells us how many arguments we need, and then it's going to return, or not return, but it's going to, yeah, I guess yeah, we are returning. We're returning a function with the length calculated based on the number of arguments that the function that we passed in takes. And then we've got an A and B, and then okay, now it gets hairy. Now we're slicing and using call, blah blah blah. So this is a much safer implementation than the my flip that I created here. But I think it's good to look at it because sometimes the implementation is just super simple. Um, so what else can we say about this? I think that it's also good to review the function here, the underscore underscore, which is a special placeholder value in case you don't want to flip it. Um, so let's just look at that in case we didn't have a flip, right? And so let's think. If we wanted to subtract 2 from 3, but pass it like this, right? And let's say we had a partially applied function. I'm going to reuse this name. So yeah, so we take an A and Z, an A and Z, and then we would say r dot subtract, and we would know the second number, right? So let's say like whatever we're doing, whatever number we pass in, we want to subtract 3 from it. So actually, I'm going to call this subtract by 3 and comment that just in case. And so subtract by 3, so that would be the second argument. That would be our Z. So we want to say subtract Z, but see, that's the first argument. So then that's where we will use the r dot underscore underscore. And that should work. All right, so about 5. So let's do like 10, but we don't need the second argument anymore. So that should give us 7, I think, but it doesn't. It gives us a function back. R dot subtract takes 2 arguments. I'm providing 2. Oh, yeah, I don't need 2 arguments anymore. So in fact, I'll just change this argument to an n for number. That still gives us a function back. Ah, I see. Do I see? Maybe I don't see. Okay. What is the argument it's expecting? So sub by 3, and now we're back to underscore underscore when we're really looking at flip in this video, but since they're so related. And I also, as I was rewatching the original series, I think Christopher got stuck into something like that, and it was a side note, so he moved on, where he got something to work with flip, but it wouldn't work with underscore underscore. Um, but what if we don't? Let's not partially apply this yet. Let's just work with it here and say r dot subtract um, r dot underscore underscore and 3. And then when we pass 10 to it, will that work? Yeah, that works. Okay. All right. So now we've got our idea of referential transparency, right? So that means that if we take this bit here and okay, I see already, I see what I've done wrong, but I'm just going to go through it. So we take that out and replace all of this with that. The referential transparency definition tells us that this is the same thing as this. So we should just be able to put sub by three. Oh, sub by three here. Goodness. And that should still work. Should still get seven. And we do. So I think I was just implementing wrong. Um, yeah, sub by three. And then I wonder if we could flip that. So like what if we did art up flip sub by three? I'm gonna call it sub three because we're flipping it. Just don't want the function name to mess this up. So that would be sub three. Uh, comment that out. All right, so now we've flipped sub three. So that means that three will be the first argument, and this guy should be over here on the right. So we should be saying if I use 10 here, it should give us negative something. Uh, if it's not a number, I've grown to really dislike not a number. Uh, but let's think that through. Let's we get not a number. So what we're saying is r dot subtract 3 minus 10. Oh, is it that something happens when there's no curring allowed when you use this underscore option? Could I do, is it going to work if I pass 10 as the second argument instead of separate parentheses? Then we get a function back, takes one more argument. I'm just going to pass it an argument. I don't know what it's going to do. Yeah, get not a number again. But there is something strange, something unknown about using this. And it could just be I'm doing something wrong, or it could be something that in Ramda there's a little detail that you need to know. Because I'm flipping it back. So r dot flip, let's see if I do it in longhand. If I intended to flip it, but I didn't have the flip function, I could say r dot subtract 3 and r dot underscore underscore. Like that's not a complete function, but let's see what the result you get. Let's get a function with one argument, and then we call it with 10. Yeah, and that gets us -7. So it works that way. But I mean, this is pointless because it should also work like this. Yeah, and it does. Or, of course, that. Yeah. So, I mean, I guess, if we're talking about flip could be really useful when we're dealing with functions that we did not create. And of course, that's not going to help us with currying. But anyway, if anybody knows why we're not getting the same results when we try to curry a function with the r dot underscore underscore, please let me know in the comments. But the simple version of flip is takes the first two arguments, swaps them, so you can pass the arguments in the opposite order. The other thing you could do, of course, is uh, let's say, let me get rid of all of this. If we didn't have flip, we could do R dot pipe, and then we could say R dot reverse, probably, and then R dot subtract, and then call that with 3 and 2. If that's valid syntax, that gives us a function back. What I was thinking is, I pass it. Oh, yeah, second. It's an array that needs reverse. I could pass it as an array. So we give it 3, 2, and then it should produce 2, 3, and then subtract with 2, 3. How do we spread in Ramda? Because we pass it an array to subtract, but we need a way to. Let's come on. Is there a spread? Because we need to turn it. Uh, we need the arguments. We don't need an array of arguments. So yeah, spread doesn't have a spread. There's that call and apply thing, but I'm still a little hairy on that. And let's be honest, none of us have ever used bind, call, or apply when we've written code. And it's probably the first thing that made us question uh, ourselves as we were learning JavaScript. The first time you get to, everything makes sense until you get to call, bind, and apply. And then you're thinking, like, oh man, I don't really understand this, but nobody's ever used it. I mean, somebody obviously has, but in our daily lives, we don't really use it. Uh, but I'd love to be able to reverse this list here, 2, 3, and call it with 2, 3. I mean, if I put the points in here, I could do and Z. Wait, no, I couldn't. It would take an X's and then spread it and then call it with X's. Is this right? No, that doesn't work either. So maybe you'll come across and find some way to spread without using an operator because I want to keep it point free if I was doing something like this. So, I mean, you can see it's not trivial to do this. So that's why it's good that the flip method works. Um, could I flip here? I don't think, no, because you need the function to flip. It's not taking the arguments and flipping the arguments and saying flip the function. So, yeah, this won't work. I thought it was pretty easy to implement yourself, but obviously it's very useful. Uh, we use this a lot so far. So I think I'll end it here. If anybody has any insight into this or to anything that I was doing, um, please let me know in the comments. Otherwise, we'll pick up in the next video and look at flow. I have no idea what flow does, so we'll learn together. I'll see you in the next one. Thanks for spending your time with me. Tell a friend.